Hi everyone. So in today's session we are going to discuss about functions in detail. Okay. So I'll be starting from the very basics of functions like what is function and then we'll discuss the different types of functions. Alright, let's begin. So before I start with the session, let me just tell you a bit about myself. My name is Aishwarya and I have done my masters in maths from University of Delhi. Prior to that, I did my graduation in maths from Miranda House University of Delhi. In total, I have more than 4 years of training experience and I have trained for various entrances like CAT, GRE and GMAT earlier. Let me just tell you a bit about myself. Okay. Now let me just explain you what are the benefits of Plus and iconic subscriptions that Unacademy offers you. So if you go for the Plus subscription, you will have access to the classes from India's top educators. The classes are live and interactive. You can get your doubts clarified within the class itself. You get structured courses. All the courses are very well structured and are made by our top educators. All right. And the notes are downloadable after each and every lecture. You will also have access to the live tests and quizzes that happen on our platform on regular basis. All right. So along with the benefits of Plus subscription, we have one more kind of subscription, that is our iconic subscription. So in the iconic subscription, all the benefits of Plus are already there, and along with that, you will get access to the personal attention from your educator. OMET's preparation is also there. You get expert guidelines about MBA and what should be your planning strategies, and everything is told to you by the educator. You get test analysis of each and every mock test that you give on our platform also. Okay, so this is the price of our CAT Plus subscription. So for 12 months the price is 17,500 and for 24 months the price is 21,000. So over this fee you can get the instant 10% off if you use the code AAISH10. Alright, now this is the price of our iconic subscription, 30,000 for 12 months and 41,000 for 24 months. Here also you can use the code AAISH10 to get the 10% off. Alright, now this is something I would like to inform you that the prices are going to increase from 1st of April. So right now I just told you the price of our Plus subscriptions and for our iconic subscriptions. Okay, so you will be able to enroll at these prices till 31st of March. Okay, so right now is the best opportunity for you to enroll for these courses and start your preparations with us. Because if you are planning to take the subscription, right now would be the best time. From 1st of April, you would have to enroll at these increased prices. Alright, let's begin now. Okay, so let us understand what is a function first. So a function is a rule that associates every element of set A to a unique element of set B. Okay, so let us understand this in detail. So suppose if I have a set A and another set I have is B. So since these are sets, they will have certain number of elements in them. Let us take the elements in set X as in set A as X, Y, Z, W, in set B as A, B, C, D, E. Okay, so these are the different elements in set A and B. Now, if I have to define a function from A to B, okay, I will define it in this way, that it is a rule that associates every element of set A. Now every element is very important here because every element of set A, whether it is X, Y, Z or W, each and every element should be associated with some element of set B. Okay, but this rule is not necessary for set B. In set B, it is not necessary that every element is associated with some element of set B. It means you can leave a few elements of set B. That is okay. Alright. Now to a unique element. Another important point in the definition. Unique means X should be associated with just one element of set B. X cannot be associated with two elements of set B. Alright. Is the definition of function clear to everyone? Yes, please give me a thumbs up or say yes or okay in the chat box if the definition of function is clear to you. Okay, all right. So this is the definition of function. Okay. Now let us understand a few terms related to functions. Okay. Now this is f. F is denoting the function from set A to B. So this is how we denote it. This is how we represent it, that f is a function from set A to set B. Okay. Now what is domain? Domain is the set for which the function is defined. All right. So domain is the set on which function is defined. Alright, so in this case it is set A. Okay, so the domain of function f is A. Now what is codomain? Codomain is the set of images. Now I'll explain what is an image. So codomain here is your set B. Okay, this set is known as the codomain of a function. Alright, so like in the definition of function, when I explained the definition of function, I said that every element of set A should be associated with some element of set B, but it is not necessary that every element of set B will be associated with some element of set A. Okay, so range is the set. Okay, now let me just explain you what is range. So range is the part of codomain. Okay, it is a subset of codomain. How? So this is the set containing the elements which to which set A elements are related to which set A elements are associated with. Okay, so range is a subset of codomain. Now there is a term called image. Now let me explain you what is an image. So if this is an element X, this is associated with the element A of set B. So I will write this as f of x is equal to A. Okay, then A is the image of x. Okay, I hope I am clear. So range is the set of images. Okay, so range is the set of images of the domain of a function. Okay, I hope this is clear. The definition of function we have discussed so far. Okay, now let me just give you an example. So suppose there was there is a class, okay, of BSc Maths students. So in BSc what happens is that there are 3 divisions. When you give the exam, when you get your degree, so there are 3 divisions offered to students. Some students get the first division, which have more than 60% marks. Okay, then students get second division if their marks lie between 50 to 60%. Okay, and some students get third division. Okay, if their marks are below 50%. Okay, so these are the divisions we have in BSc Maths degree. Then what? Let us take a function. So there is a function f from set A to set B. This is a function f from set A to set B. Now let's see what is in set A. So in set A there are students of the class, students of BSc Maths. Okay, let us take the students as A, B, C, D. These are the different students in the class. Now what is set B? Set B is the divisions. It's the set of divisions. Okay, now each and every student will appear for the exam and will get a division. This is sure. There is no student that will be left behind in set A, hence satisfying the every element of set A condition of a function. Then every student will get a unique rank. Now is this possible that student A and student B both get rank 1? Yes, it is possible. So all the students, 2 students can have 1 rank. So A can be associated with 1, B can also be associated with 1. Then it is possible C gets second rank and D also gets a second rank. Okay, so this is absolutely possible. Hence, this is a function. Okay, so now if you see, one of the element of set B is remaining. No element of set A is related to it. Okay, hence here I would say range of the function f is equal to 1, 2. Okay, whereas the codomain is codomain of this function is the entire set B, that is 1, 2nd and 3rd, all the 3 divisions. Okay, so I hope the difference between range and codomain of a function is clear. Okay, now what is the domain here? Domain is the students ABCD. Okay, now please think, can one student get 2 ranks? Can a student get 2 divisions? No. Okay, so this is what you have to ask yourself if you have to determine whether a given rule is a function or not. Okay, so this is a function because one student cannot get 2 divisions. Okay, so that is why the element associated with each and every term, each and every element of the each and every element of the domain is unique. Alright, I hope this is clear. The definition of a function is clear. Okay, all right. Okay, so so far we have discussed about the function, what is the domain, what is the range of a function. Now we are going to discuss how do we calculate the domain and range. Okay, now for example, okay, let us first recall the definition of the domain. Domain is the set for which the function is defined. Okay, set for which the function is defined. Range is the set of values of function. So for example, if I have a function fx, then x is my input and my input is x and my output is y. Okay, so this y actually represents the value of the function. So I can say that whatever I input in a function comes from the domain, and the output that I get from a function is the part of the range. Okay, I hope this is clear. Now, for example, if I have a function fx is equal to x plus 7. Okay, so this is a function. I have to find the domain and range of this function. Let's see how will I do that. Okay, so domain is the set for which the function is defined. Okay, so this function is, can I take the value of x as 0? Yes, so if I take x as 0, I will get the value of fx as 7. If I take x as 1, I will get the value of function as 8. Similarly, if I take x as 100, I will get 107. If I take x as 10,000, alright, I'll get 10,007. Alright, so whatever value I give to x, I will get a value of fx accordingly. So basically, I have tried different positive integers. I can even give fractional values. Okay, I can even give negative values to it. It means fx is defined on the entire real line. Okay, so I can give values of x from the entire real line. It means domain of f is the set of real numbers, which is R. Entire real line is the domain of fx. Okay, now let us see what are the values that this function can take. Okay, now see, can the value of the function be equal to 0? Yes, so fx would be equal to 0 when the value of x is equal to minus 7. Okay, so at these different values of x, we can calculate the value of fx accordingly. Now, if you notice, fx can also be negative, fx can also be positive, and fx can also be 0. Hence, fx can take up all the values of the real line. Therefore, range of the function is also equal to R. That is the set of real numbers. Alright, I hope this is clear. Okay, now let us try to find domain and range of the function fx is equal to under root x plus 7. Okay, let us discuss what is the domain of this function. Now see, can I take the value, just think in this way, that can I take the value of x as 0? Yes, the value of the function fx would be equal to root 7. Can I take any negative value? Yes, I can take minus 2 also. I'll get the value of the function as root 5. If I take the value as minus 7, I will get the value of fx as 0. But if I take x as minus 8, I will get value of the function as minus root 1, which is not defined as a real number. Okay, so since here we just are considering all the real numbers, minus under root of a negative number cannot be calculated. Okay, so I cannot calculate the root of a negative number. Therefore, domain is the set of values of x for which this function is positive. Okay, since this is under root, we know that this value of fx will always be positive, and root of only positive or zero function is zero function can be calculated. Therefore, so domain is the set of value for which x plus 7 is greater than or equal to 0. Okay, so let's see in this case. In this case, x has to be greater than or equal to minus 7. So the domain is the set from minus 7 till infinity. Now minus 7 is also inclusive in this. Alright, so this is how we calculate the domain of a function. Now what is the range here? Now see, as I said earlier, this function cannot take any negative value because this is under the root. It means the value of fx will always be greater than or equal to 0. 0 when x is equal to minus 7. Hence, range of this function is the positive real line, that is 0 to infinity. 0 is also inclusive. So this is how I can calculate the domain and range of the function that is given to me. Alright, let's do one more. So suppose if I have the function fx is equals to 1 upon under root x plus 7. Okay, now let us try to find the domain. So domain is the set of values of x for which the function is defined. Okay, so clearly I can see that fx is not defined for yes, if I take the value of under root, see the value of under root x plus 7 should be positive. This value cannot be equal to 0. Why? Because if this value would be equal to 0, then the function will take up 1 by 0 form, which is not defined. Alright, so therefore I have to consider the values of x for which the denominator is greater than 0. So fx is not defined for values of x for which root x plus 7 is less than or equal to 0. Therefore, the value of x plus 7 under root x plus 7 should be greater than 0. Okay, so this is possible only when, okay, so this thing has to be this thing could be see, root x plus 7 should be greater than 0. This thing cannot be less than 0. Let's see further. Okay, so x plus 7 is greater than 0 means x should be greater than minus 7. Therefore, minus 7 to infinity is the domain of this function. I cannot consider minus 7 because at minus 7 the value of the function would be equal to 1 upon 0, hence not defined. Okay, I hope this is clear to all. Okay, so this is how we calculate the domain of the function. Okay, now let's see how do we calculate the range of this function. Okay. So range is the set of values of fx. Okay, so this is a set of all the values which fx can take. Okay, so can fx be equal to 0? No. Will the value of fx be positive? Yes, this value will always be positive as numerator is positive and the denominator will always be positive. Okay, so this can take any value, but see, this function will always be greater than 0, this I know. So I cannot include 0. Okay, I cannot include 0 in this, but can this function be greater than 1. Let us take a value of x for which this function is greater than 1. So suppose if I take x as 100, let us try taking x as 100. So if I take the value of x as 100, I will get under root 1 upon 107. So anything I take will always be, the numerator will be greater than, numerator will be a positive number, but the numerator will always be equal to 1 and denominator would be some number. Alright, so basically the range would be from 0 to 1 only, because the value of this function will always be less than 1. Can this be equal to 1? Let's see. So for this function to be equal to 1, I will have that root x plus 7 is equal to 1. So if I square both sides, I will get x plus 7 is equal to 1, which means that x should be equal to 1 minus 7. So x should be equal to minus 6. So if I take the value of x as minus 6, then this value could be equal to 1. Hence, function, this can take the value 1. So the range of this function would be from 0 to 1. Okay. So just to verify this, let us take some other value of the function. Let us take this value of the function as 2. Let's see if this value could be equal to 2. So if 1 upon root, this is equal to 2. So then I will get 1 is equal to 2 into under root x plus 7. Squaring both sides, I will get 4x plus 7. So this will give me 1 is equal to 4x plus 28. So if I simplify this further, I will get the value of 4x is equal to minus 27. Okay. So from here, I get the value of x as minus 27 by 4, which is equal to minus 6 point, sorry, this will be, yeah, 6.9 something. Okay. Alright, so I hope this question is clear to you, that how do we calculate the domain and range of a function is clear. Let us continue further. Alright, now let us understand what is one-to-one function. So like as we discussed before, suppose if I have a function f from a to b. So this is a function f from set A to set B defined. Okay. Now there are certain elements in set A and certain elements in set B. Okay. So a function is a one-one function if all the elements of set A are associated with exactly one element of set B, this way. So if A is element, it is exactly, it is associated with X. Now no other element could be associated with X. Okay, so B with Y, C with Z. Okay, so this type of function, when each element is associated with a unique image, okay, and every element of set B has just one pre-image, then the function is known as a one-on-one function. Okay, now let's see what is a onto function. Again, let us take a function from set A to set B. Okay, so this is a function f from set A to set B, defined in a certain manner. Some rule is given. Now what is an onto function? Now x, y, z, w, a, b, c, these are the elements of set A and B. Okay, now a function is said to be an onto function if no element of set B is remaining to be associated with some element. If all the elements of set B are associated with some element of set A, then the function f is known as an onto function. I hope I am clear with the definition. Now from here you can also see that a function is an onto function if this way all the elements are associated with some element. Okay. Okay, so all the elements have a pre-image in set A. No element of set B is remaining. So in the case of an onto function, range is equal to the codomain. Range is equal to the codomain. Okay, so I hope the definition of a 1-1 and onto function clear to everyone here. Okay, now this is another type of function, a constant function. What is a constant function? Suppose if the function is defined from set A to set B, then whatever is the value uh, of an element of set X, it will always give K as the output. So whatever input you give in this function, the output will always be K. So in this case, the set B is equal to K. No, set B could be anything, sorry. The range is equal to K. Okay, so range of a constant function is equal to K, where your K is a constant. Alright, let us take a few examples of constant functions. For example, I can say if it is given that f of x is equal to 100. So whatever values you take for x, this function will always be a constant. So if I take x as 100, the value of y, the value of the function would be equal to 100. If I take x as 1000, y would be equal to 1000. Y would be equal to 100 only. Okay, if I take x as minus 500, then also y would be equal to 100. So no matter what value you input in x, what value you give to x, y will always be a constant value, that is 100 defined in this example. Alright, I hope the definition of constant function is clear. Now let us discuss what is an identity function. Identity function means your input would be equal to output. So for example, I have a function from A to B. So function f is defined from set A to set B, where fx is equal to x. So this is known as the identity function. Okay. So in this case, your range is equal to codomain. Sorry, range is equal to domain. Okay, because all the numbers are associated with themselves. Okay, so this is an example of an identity function. This is also denoted by small I. Okay, I hope the identity function is clear. Alright, let us continue. Inverse of a function. Okay, now see, till now we discussed that f is a function from A to B, where A is your domain and B is the codomain. Okay, and range is the subset of B. Okay, now similarly I can define one more function g from B to A. So this is also what can be defined, that g is a function from B to A, reverse. Okay, so g is an inverse of f. Okay, and how do we get that? For example, if I have a function f of x is equal to x square plus 2. This is some function of x, right? Now I have to find the inverse of this function. Then as I know, as we have discussed earlier also, that fx is denoted by y. So let us replace fx by y. So I will get that y is equal to x square plus 2. Now I will write x in terms of y. So from here I get that x square can be written as y minus 2, which can further be written as x can be written as under root of y minus 2. Okay, so now this function is your inverse function. Okay, let's see what is the inverse now. So inverse function can be written as g of y is under root y minus 2. Now since x and y just represent the variables, I can replace this yx and get g of x is equals to y minus 2. Hence this is the inverse function. Okay, so this is denoted by f inverse. Minus 1 is written in the superscript to define the inverse function. So here g is your inverse of f. Okay, so just so if there is a function f which is defined in this manner, that a is the input and b is your output, where your a belongs to set a and b belongs to set b. Now f inverse would be exact opposite of this. This would be b comma a. Okay, this would be same. Okay, so this is how inverse of a function is defined. Okay, I hope the definition of inverse of a function is clear. Now let us discuss what is composition of functions. Okay, now see, if I have a function fx, in this function x is my input. Okay, x is the independent variable or the input. Because I am inputting a number in this function, what if I change this input with some other function? So suppose if I have other function g of y maybe. Okay, let us take other function as g of y. Now in the place of x, I am going to input g of y in this function. So I will get f of g of y is equal to something. So this is so in the place of x, I have input g of y. So this can be written as f o g of y. Okay, or you can we can say it as fog of y. So this is the composition of function f with y. Sorry, f with g. Similarly, I can input the value of function f in g. Let's see how will I do this. So this is how I can do this also. So I will get gof of x. Yes, hi Shravan. I hope you are understanding what I'm saying here. Is the definition of function and all these basic definitions clear to you? Yeah, only you are there in the lecture. I think other students are preparing for CMAT, that is tomorrow. Yes. Shravan, do you have any questions? I hope everything is clear till now. Is there any term that you would like me to discuss again? No doubt. Okay. Now this is the composition of f with g and this is the composition of g with f. Now it is not necessary that fog of a function is equal to gof of a function. Okay, this is not necessary. So this is an assumption that you should not make. This may be equal for certain functions but not every time. Okay, so this is the rule. Now let us take an example of a function. So suppose if I have a function f, define that f of x is equal to x square plus 17x. Okay, so let us take other function g of x, which is x plus 3. Let us take this as under root x plus 3. Okay, now let us find the composition of functions. So if I have to find fog of x, I will do it in this way. Okay, I will put the value of, in the place of x, I will input gx. So I will get this as f of gx, which is equal to f of under root x plus 3. So basically I am going to replace x with root x plus 3. So I will get root x plus 3 whole square plus 17 root x plus 3. So this function is the fog of x. Now let us calculate GOF of x. Okay, so GOF of function here is, in the place of x I am going to input fx now. Okay, so this would be equal to g of x square plus 17x. So this will give me under root x square plus 17x plus 3. So now are these two functions, are these two functions equal? No. So therefore I can say that fog of x is not equal to GOF of x always. Alright. Yes. Hi Saurabh. Yes, so in this class, in this particular class, I am going to discuss the basics of functions, only all the basic definitions and terms related to functions. But surely in the next class, we will be discussing I will be discussing questions of higher difficulty level also. Alright, we will be discussing about signum functions and modulus functions, all this greatest integer function, least integer function, everything I will be discussing in the next lecture. Alright. Okay, so I hope this is clear. Now, let us discuss a question. Okay, so please solve this question. The function is f of x is equal to 1 upon under root x plus 2. Now, this is mod of x plus 2. Find the domain. Okay, so this is the question. Find the domain of f. Please try to solve this and tell me the answer. Yes, any answer yet? What would be the domain of function f? Yes, Saurabh, Shravan, can you answer? Okay, let's see how will we calculate the domain of this function. Now, since this is a function, in the denominator we have modulus. It means the denominator cannot be negative. Now see, this function is defined for all the values except for the values denominator is 0. Okay, so basically we know that denominator cannot be equal to 0. And denominator of this function is equal to 0 when the value of x is minus 2. So at the value of x is equals to minus 2, the value of fx would be equal to 1 by 0, that is not defined. Alright, therefore the domain of this function is the entire real line except minus 2. So this is the domain of function f. Okay, I hope this is clear. Let's continue. So we have already discussed about composition of functions. Okay, now I am going to discuss what are real functions. So suppose if I have a function from set A to set B. So function f is called a real value function when B is equal to the real line. Okay, so if b is the set of real numbers, then this function is a real function. Also, one more condition in the definition of real function is that a should be a subset of r. Okay, so any real valued function is the function whose codomain or the range is equal to the set of real numbers. All right, so I hope the definition of real function is clear. Okay, now let us discuss what are the different operations. So different operations in mathematics are plus, minus, division, multiplication. So all these four operations are valid in case of real functions also. Okay, let us discuss. Okay, so for real functions, suppose if I have a function f of x and other function is g of x, so I can define f plus g of x also. How? It would be the sum of fx and gx. Okay, this is how I define the sum of two functions. Similarly, I can define the difference of two functions in this way. This is f of x minus gx. Similarly, if I have f into gx, the product of fg, the product fg is defined as fx into gx. Also, f upon g x is defined by fx by gx. Okay, so it is quite simple. This is how the operations on real functions is defined. Okay, now why knowing this and what is the application of these operations, this is what I am going to tell you now. So suppose if the domain of a function fx is d1, okay, and domain of function gx is d2, okay, then using this you can find the domain of f plus x, f minus x, sorry, f plus g, f minus g, then domain of f plus g of x, okay, and f minus g of x, f into g of x, and f upon g of x, okay, is given by, this domain is given by d1 intersection d2. Okay, so basically you take the intersection, the common part of both the domains to get the domain of functions f plus g, f minus g, fg and f by g. For example, if I have a function of this form, if I have this function fx is equal to x square upon x plus 3. Okay, so how will I calculate the domain of this function? I will calculate the domain of numerator, then I will calculate the domain of denominator. Okay, then I can see what is the common domain. So what is the domain of x square? This is defined for all the real values. So this is defined for all the real values. X can take a positive, negative, 0, any value. Now let us discuss about x plus 3. So x plus 3 can also take up all the values. This is a linear function, so can take up all the values. So the domain of fx will be r intersection r. So this is equal to r. Okay. So this was not a very good example of it. So if I take, this is a good example. The denominator is x plus 3. The domain of this is not equal to r. I cannot take x as minus 3, right? So if x is equal to minus 3, the value of the function would be equal to, the denominator of the function would be equal to 0. So then division won't be possible. So the domain of the denominator is r minus 3. So the domain of the entire function would be r intersection r minus 3. Therefore, the domain is r minus 3. Alright. So this is how we calculate domain of quite complex functions where you cannot find it directly. You can break up it into two functions using plus, minus, division or multiplication, and then you can get the domain of two functions. Okay, I hope this method is clear. If this method is clear, please give me a thumbs up if this question is clear to all here. Okay. Alright, now let us discuss about even and odd functions. Okay, so first let us discuss about even function. So if there is a function such that fx is equal to f of minus x, then this is an even function. Okay, so a function is an even function if the value of fx is equal to f of minus x. For example, let us take the example. If I take f of x is equal to x square, okay, x square, then f of minus x is also equal to minus x whole square, which is equal to x square, which is equal to f of x. Hence, I get that f of x is equal to f of minus x. So, it means this is an even function. Okay. Now, let us understand what is an odd function. Odd function means if the value of f of minus x is equal to minus of fx, then this is an odd function. For example, let us take f of x as x cube. Okay, let us find f of minus x, which is equal to minus x whole cube, which is minus of x cube, can be written as minus of fx. Okay, so hence we got that value of minus f of minus x is equals to minus of fx. Hence, this is a odd function. Alright, so I hope the definition of even and odd function is clear. Okay, alright. Alright, so now let me just give you some information. So this is the information about the batches that are going to start recently on our platform, on the Unacademy platform. So from tomorrow, that is 31st of March, we are going to start a batch. And a new batch is going to start from 1st of April. Two batches are going to start from 1st of April. So this is a verbal ability and reading comprehension expert 2.0 batch. Okay. And this is a late night weekday batch. Alright. So these are the batches that are going to start. So you still have time to enroll for the course and start your preparations as soon as possible. Also, now these are the students who have scored more than 99 percentile in CAT 2020. So you guys can also join this list if you start your preparations with Unacademy now. So in the iconic subscriptions, you get help from the personal educator, personal mentor is given to you. You get regular test analysis and reports. The detailed score analysis is given to you after the end of each and every mock, which is very crucial for preparation. Also, OMID's preparation is included and all the benefits of Plus subscription are also there in the iconic subscription. Alright, now this is the weekly scholarship test that we conduct. Okay, so for this week, this is going to be held on Sunday at 12 p.m. sharp. The syllabus is same as that of CAT. You will get verbal ability, Quant and LRDI based questions only. The duration of this test is for 60 minutes. Okay, so you can appear for this test. Alright, to unlock this test, you can use the code AAISH10, and if you score well in this test, then definitely you can get some good scholarships up to 55 lakhs plus. Alright, so make full use of this opportunity, participate in this test. Now this is the Ask a Doubt feature, which you should make use of. So you just have to go to your Unacademy Learning app, click on Ask a Doubt, take the picture of the question you want the solution for, crop the picture so that the question becomes more readable and highlighted. Select the correct subject to which the question belongs and submit it on our platform. Then our educators will solve the question and share the detailed explanation with you as soon as possible. Alright. Now this is the name of our YouTube channel and this is the Telegram channel. Please subscribe to the channels to get regular updates about my classes, my special classes as well as my YouTube classes on the platform. Okay, now I would like to tell you what are the steps to go for the subscription. So the steps are pretty easy. You just have to go to Google Play Store, type Unacademy there and install the Unacademy Learning app. As soon as you'll install the Learning app, as soon as you'll install the Learning app, the app will ask you to select a goal for yourself. So you select CAT as the goal there and then you click on Get Subscription. As soon as you click on Get Subscription, the app will ask you to choose between Plus and Iconic, that you can choose accordingly and use the code AAISH10 to get the subscription. Also, this code can be used to get 10% off Also, this code can be used to unlock my special classes on the platform. Okay, so on the Unacademy app, you can unlock my special classes. You can come into my live classes free of cost if you use the code AAISH10. Alright. Alright, so I hope you enjoyed the class. I hope some concepts of functions are clarified in your mind. So if you like the video, please share it with your friends and family so that they can also get benefits from it.